Brazosport Planetarium presents Water in the Jupiter System. The Center for the Arts and Sciences in the BASF Planetarium. Here is Jupiter and 3 of its largest moons, seen from Brazosport through David Babb's telescope. It is an exciting moment when NASA's Juno spacecraft arrived at Jupiter and began to orbit the planet with an Hohmann transfer, which allows for the largest payload with the least amount of fuel. Data from Juno's first 8 flybys found that water makes up about 0.25% of the molecules in Jupiter's atmosphere along the equator. Jupiter's atmosphere is mostly hydrogen and reacts with oxygen to make the atmospheric water. Since Jupiter has such a large mass, the planet contains much of the leftover gas and dust from our solar system's formation. Understanding its water content can help scientists learn how our planets originally came together. This image captures swirling cloud belts and tumultuous vortices within Jupiter's northern hemisphere. In general, the darker cloud material is deeper in Jupiter's atmosphere, while bright cloud material is higher. The bright clouds are most likely ammonia or ammonia and water mixed with a sprinkling of unknown chemical ingredients. Astronomers hypothesize that a layer of high-pressured water lies in a layer deep within Jupiter's gaseous layers. This is what Earth would look like if we dropped it into the great red spot on Jupiter. Water can be found in planets across the solar system, from small planets like Earth to giant Jupiter. Jupiter's mass is more than all the other planets of the solar system put together. If Jupiter's mass was a little bit greater, it would be classed as a star. Because this Hubble Space Telescope observation was taken in near-infrared light, Jupiter appears in pastel colors. In the near-infrared, methane gas in Jupiter's atmosphere limits the penetration of sunlight, which causes the clouds to appear in different colors depending on their altitude. The black circles are cast by 3 of Jupiter's largest moons, Io, Ganymede, and Callisto. The blue color of the actual moon Ganymede comes from the absorption of water ice on the moon's surface at longer wavelengths. Ganymede obviously has water. There are 79 known moons of Jupiter. These are the 4 largest and most studied of those moons: Callisto, Ganymede, Europa, and Io. Ganymede is the largest in size, larger than Mercury. It has no atmosphere. Water ice covers its surface. Polar ice is blasted by plasma from Jupiter's huge magnetic field, and because of this, frozen water molecules at the poles form random arrangements. Nearer the equator, ice crystals form. The moon Ganymede has a complex, active surface with much fewer craters than you would expect on a moon with no atmosphere to protect it. As the surface cracks or breaks, new ice rises, solidifies, and replaces the old surface. The surface shows many ice flows. Newer ice flows cut across more ancient ones. These plumes in Hubble Space Telescope pictures show possible geysers erupting from Europa's icy surface. This image of icy Europa shows surface features such as domes, ridges, and broken crust that has moved to new positions. You are seeing an area of 155 by 124 miles. The natural colors would be shades of gray. The colors you see show three different features of Europa. The bright white areas that are circled here are blasted material which exploded from the craters when the surface was hit by meteors. The reddish areas show material which is not ice. The color can be seen along ridges and near the domes where heat from inside the moon has changed the surface in some way. The bright blue color marks old icy plains. This fascinating system intrigues scientists. The NASA Europa Clipper is set for launch in 2024. The spacecraft will orbit Jupiter and take 44 flybys of Europa over an 8-year period. The Clipper will be looking for suspected water ocean beneath Europa's surface ice. It will confirm and explore the nature and chemistry of this distant ocean, if it exists, and explore the surface features on this distant moon.